At the beginning of the week, I showed you this picture, and I talked about how the structure of this part of the course was really going to be defined by the cross product of recipes like how to design functions and how to design world programs with data definitions with different structure. During the week, we saw how to design simple atomic data definitions, interval data definitions, enumerations, and itemizations. And then we designed one function using each of those data definitions. We basically completed the red box in this week. Next week, we'll do the green box. That point that you can think about the organization of the first part of the course in terms of a cross product between the form of the data and the how to design functions recipe, that point's important. But there's a much more important point that underlies that. Think about the examples we've seen this week. Think about the city name example and the best function. The inherent structure of the domain information in that case was atomic. So we represented it using simple atomic data. And that meant the template had a certain form, ... x. And that told us something about the function and something about the tests as well. And that happened with all of the data definitions. With seatnum, the inherent structure of the information is a contiguous range of numbers. So in that case, we use an interval. That formed the template a certain way, it formed the body of the function a certain way, and it told us something about the tests. In that case, that there should be 3 of them. Every example we saw this week, there was this same phenomena, which is that once we identify the structure of the information, the inherent structure of the information, that gives us the structure of the data used to represent it, which gives us the structure of the template, which gives us the structure of the function, and also we get guidance about the tests for that function. So identifying the structure of the information is really a key step in the program design, at least for many kinds of programs, the ones we're going to look at for the first 2 parts of this course. As data definitions get more sophisticated, what you're going to see is that there are different choices you can make about the data that you'll use to represent information. And by making different choices, you actually have a lot of influence on the rest of the program because of this fact that the structure of the data determines the structure of the template, determines the structure of the functions. So designing data is a very high point of leverage for designing programs. There are some programs for which that's less true, but for very many programs, this approach that we're taking in the first 2 parts of this course, this data-driven approach, does a very good job of producing the structure of large parts of the program. What we'll see later in the course is some examples where the control structure becomes dominant. And what we'll learn in that part of the course is how to blend templates based with control structure together with templates based on type comments or templates based on the form of data to produce the dominant structure of our program. But even in those programs, the form of the information determines the form of the data, and the form of the data determines the form of many of the functions that operate on the data. So identifying the form of the information remains a key step in the design of programs. That's going to be true throughout the course and throughout all programs you write. So have fun with the homework assignments, and I'll see you next week.